Welcome, my student. Our lesson today is talking about matrices. Introduction. Matrices. Definition. A matrix is a set or group of numbers arranged in a square or rectangle array enclosed by two brackets. Example: matrix in order 3 by 3 means 3 rows and 3 columns that represent the row, the first row, the second row, and the third row. But that represent the first column, the second column, and the third column, respectively. Means this matrix in order 3 rows, 3 columns, respectively. Matrix, another matrix in order 1 by 2, 1 row and 2 columns. That's the first row and 2 columns in order 1 by 2. Matrices. Introduction. Properties. Specify the number of rows and specified number of columns. Two numbers, row multiply column. Describe the dimensions or size of matrices. Matrices. E11, that's the matrix E. 1 represent the first row, 1, 1, 1. And 2 represents the second row and the third row, etc. That's the first column, the second column, the third column, and etc. Type of matrices. Column matrix or vectors. The number of rows may be any integer, but the number of columns is always 1. The number of columns, we have 1 column, but the number of rows, any number. Row matrix. Row matrix, any number of column, but only 1 row. Like that, 1 row, but any number of columns. 1 columns, 2 columns, 3 columns. And this is 1 row. It's said to be row matrix. Consists from 1 row. Type of matrices. Rectangular matrix. Contains more than the element of number of rows is not equal to the number of columns. Like that. This is a rectangular matrix. Type of matrices. Square matrix. The number of rows is equal to the number of columns. A square matrix A has an order of m. Like that. It's a square matrix. And it's a square matrix. It's square matrix in order 2 by 2. And this is square matrix in order 3 by 3. Diagonal matrix. A square matrix where all the elements are 0, except those on main diagonals. Its mean Aij equals 0 for all I equal j. Aij equals 0 for some or all I equal j. This is diagonal matrix. The main diagonals any numbers and the left of numbers equal 0. and this is also the diagonals matrix. Types of matrix. Unit or identity matrix. It's represented by this sample. A diagonals matrix with one of the main diagonal. The main diagonals equal 1 and the left equals 0. That's the square identity matrix, the sample I. Non-zero matrix. All the elements equal 0. All the elements in the matrix are 0. Matrix operations. Equality of matrices. Two matrices are said to be equal only when all corresponding elements are equal. Therefore, their sides or dimensions are equal as well. This is the matrix A in order 3 by 3, and this is matrix B in order 3 by 3 also. This is equal matrices, A equal B, because each element equal to corresponding each element in another matrix. And this matrix in order 3 by 3 and matrix B in order 3 by 3 also. Therefore, matrix A is equal matrix B. Matrices operation. Commutative property. Commutative law. A plus B equals B plus A. If we have two matrices A and B, if we add A plus B, the same result if we add B plus A. Associative property or associative law, if we have three matrices A, B, and C, we add B and C from the beginning, we add A to the result. The same value if we add A plus B and the result add to C, or addition A plus B plus C. Look to this example. If matrix A in order 2 by 3 and matrix B in order 2 by 3 also, the result matrix C in order 2 by 3. Let's adding 7 plus 1 equals 8. 3 plus 5 equals 8 respectively. Negative 1 plus 6 equal 5. 2 corresponding negative 4, the result negative 2. Negative 5 plus negative 2, the result negative 7. 6 plus 3, the result 9. Properties. If we add any matrix to the zero matrix or add zero matrix to the same matrix, the result equal A, the same matrix. The second property, if we have matrix A adding to the additive inverse, the result is zero matrix. Multiplication of matrices. The product of two matrices is another matrix. Two matrices A and B must be convertible to the multiplication to be possible. The number of columns of A must equal to the number of columns of B. The number of columns of A must be the number of row to the B. If we have two matrices A and B, to multiply A and B, we have check 1 by 3, the first matrix. The second matrix we have start from 3, means the first matrix, the column 3, then we must the second matrix, the row is 3. In this case, the result equals 1 by 1. The result equals 1 by 1. Sorry. The result in this case equal 1 by 1. We must the column of the first matrix equal the row of the second matrix. If we have matrix B, we want to multiply matrix A, matrix B in order 2 by 1 and matrix A in order 4 by 2, it's impossible to do this operation because the column not equal the row. The column of the first matrix not equal the column of the second matrix. Let's go to the second one. We have matrix A and matrix B. Matrix A in order 6 by 2 and consider matrix B in order 6 by 3. The column of the first matrix doesn't equal the row of the second matrix. It's impossible to do this problem. But if we have matrix A and matrix B, matrix A in order 2 by 3 and matrix B in order 3 by 2, we can do this operation because the column in first matrix equal the row in the second matrix. Therefore, it's possible and the result is matrix in order 2 by 2. When we want to multiply two matrices, we have multiply the first row multiplied by the first column. A11 times B11 plus A12 times B21 plus A13 times B31. And now we multiply the second row multiplied by the second column. A21 times A12, A22 times B22 plus A23 multiplies B23. And the first row multiply the second row with the second row multiply the first row. It means the first row multiply the first column and the second column. The second row multiply the first column and the second column. Let's go to solve this example. If we have two matrices, the first one in order 2 by 3 and the second one in order 3 by 2. It's possible to do this operation and the result equal matrix in order 2 by 2. It's possible to draw because the column in the first matrix equal the row in the second matrix. Multiply the first row multiplied by the first column. 1 by 4 plus 2 by 6 plus 3 by 5. Give me A11 first row and first column. And multiply the first row by the second column. 1 by 8 plus 2 by 2 plus 3 by 3. Give me A 1, 2, the first row and the second column. And now you multiply the second row, multiply the first column. 4 by 4 plus 2 by 6 plus 7 by 5. Give me a 2, 1, the second row and the first column. The last one, multiply row by second column. 4 by 8 plus 2 by 2 plus 7 by 3. Give me a 2, 2, the second row and the second column. The answer equal matrix in order 2 by 2, 31, 21, 63 and 57. Remember that if we multiply identity matrix by any matrix equal the same matrix. That is the identity matrix. 1, the diagonal matrix equal 1 and the remaining 0. Multiply any matrix, the result is the same matrix. Assume that matrices A, B, and C are convertible to the operation identical. The following are true. The first property, A multiply identity matrix equal time A equals the same matrix A. If we have three matrices, associative property is satisfied. A, B, and C. If we multiply B and C and multiply A respectively equals multiply AB and multiply C respectively also equals A times B times C. Distribution multiplied over addition. If we multiply A matrix times matrix B plus A times matrix C equal A times matrix B plus C. The distributive property is satisfied in multiplication in matrices. If we have matrix A plus B multiplied by C, the same result if we distribution multiplied over addition from the left. AC plus BC. Caution: if AB not generally equal to BA, BA may not to be conformable. If AB equals 0, neither A nor B necessarily equals 0. AB not generally equal to BA. BA may not be conformable. If we have matrix T and matrix S, T by S when multiplied give me this matrix. But if we multiply S by T, give me another matrix. Therefore, AB doesn't equal BA. Example: if matrix A, a square matrix, in order 2 by 2, -1, 2, 0, 3, then prove that A power 2 minus 2A minus 3I equals 0. A power 2 is equal to -1, 2, 0, 3 multiplied by itself. -1, 2, 0, 3. Multiply the first row by the first column. -1 by -1 equals 1. 2 by 0 equals 0. That's A 1 1, the first row and the first column. Let's go to multiply the first row by the second row. Negative 1 by 2 equals negative 2. 2 by 3 equals 6. 6 minus 2 give me 4. The second row multiply the first column. 0 by negative 1 equals 0 plus 3 by 0 equals 0. Multiply the second row by the second column. 0 by 2 equals 0. 3 by 3 equals 9. That's the result. Multiply A by A. Matrix A by matrix A. Okay. Direct substitution. 1, 0, 4, 9 minus 2A, negative 2, 4, 0 and 6 minus 3I, 3, 0, 0, 3. The result, 1 plus 2 equals 3. 3 minus 3, 0. 4 minus 4 equals 0. Minus 0 give me 0. 0 minus 0 equals 0. 9 minus 6 minus 3 equals 0. The result is 0 matrix. Therefore, the left hand side equal the right hand side. That's the solution. Matrix A multiply matrix A give me A squared minus 2 matrix A minus 3 identity. The result equal 0. Transpose of matrices. Transpose of matrix. The transpose of A denoted by AT. If we have matrix in order 2 by 3, the transpose of matrix give me matrix in order 3 by 2. Convert the first row to the first column and the second row to the second column. To transpose, interchange rows and columns. The dimensions of AT are the reverse of the dimensions of A. If we have matrix A in order 2 by 3, 2 rows and 3 columns, the transpose matrix give me matrix in order 3 rows and 2 columns. The first row change to the first column and the second row change to the second column in order 3 by 2. Properties of transpose matrices. If we have matrix A plus B all transpose, the result equal A transpose plus B transpose. Properties 2. If we multiply A matrix A by B, all transpose equals change B transpose times A transpose. If we have K is a constant, all transpose equals K A transpose. A transpose, all transpose give me the same matrix A. Let's check. Check to the first property. A plus B all transpose equal A transpose plus B transpose. If we have matrix A, matrix B, and adding operation A plus B, the result equals A plus B. The same if we add transpose, convert the first row to the first column and the second row to the second column. A transpose, transpose لل A, and B transpose equals A transpose plus B transpose, the same result. A plus B all transpose give me matrix in order 3 by 2, and A transpose plus B transpose give me the same matrix. The same matrix. AB all transpose equals B transpose A transpose. Let's check. If we have matrix A multiply matrix B, the result column matrix 2 and 8. Transpose matrix 2, 8, 1 row. Transpose B give me this matrix 1, 1, 2, first row. Multiply A transpose, the result the same matrix 1 row 2, 2 and 8. Therefore AB all transpose equals B transpose A transpose. Symmetric matrices. A square matrix is symmetric if it's a square to its transpose. It means if we have matrix A equals transpose matrix A, therefore it's called symmetric matrix. Matrix A in order 2 by 2, A, B, G, A, B, B, G. The same matrix if we transpose it, because it's a symmetric matrix. Symmetric matrix, it means mean diagonal, main diagonal, and B and B and this number the same of this number. If we transpose matrix A, give me the same matrix. Look at this example. Skew symmetric matrix. Skew symmetric matrix, A is called skew symmetric matrix if and only if A, matrix A, equal negative A transpose. Example, the main diagonal equals 0. And this number 5 symmetric with negative 5. Negative 3, 3. Negative 1, 1. This is the main diagonal, and each element 5 and negative 5, additive inverse. Negative 3, positive 3, additive inverse. Negative 1, 1. Each element additive inverse to another element. That's the skew symmetric matrix. Equals negative A transpose. If we transpose this matrix, convert the row to the column, and the second row to the second column, and the third row to the third column. What did use? 5 and negative 5. Negative 3 and positive 3. Negative 1 and positive 1.
Therefore, the same matrix is called skew symmetric matrix. If we have this matrix is symmetric matrix, then find the value of x and y. Skew symmetric matrix, therefore 2x equals negative 4. Equation from the first degree one variable, divided both sides by 2, therefore x equals negative 2. Because this is the main diagonal and this element equal to this element. X plus 2y, x plus 2y equals 8. Replace x and put negative 2 instead of it, plus 2y equals 8. Solve this equation. Two variables from the first degree of two variables, we get 2y equals 10. Divided both sides by 2, therefore y equals 5. If we have skew symmetric matrix, then find x, y, and z. To solve this example, since the matrix E is a skew symmetric matrix, therefore negative 2z equals negative 6. Additive inverse. Divided both sides by negative 2, we get z equal 3. The second one, z plus 3 equals 3x. Since z equal 3, 3 by 3 is 6, equal 3x. Divided both sides by 3, therefore x equals 2. The third one, 3y plus x equals 7. Solve equation from the first degree two variables. Replace x and put replace x and put 2 instead of it. 3y minus 2 equals 7. 3y equals 9. Divided both sides by 3, therefore y equals 3. The value of x equal 2, the value of z equal 3, and the value of y equals 3. Determinant. Determinant of the matrix. It's denoted by determinant E. If we have matrix E, put a determinant at this example 1. Determinant E multiply E11 by E22. minus A12 multiply A21 to get the determinant of matrix 2 by 2. In this case, 3 by 2 minus 1 by 1. 3 by 2 minus 1 by 1. Give the result equals 5. Then the determinant of matrix A equals 5. For a matrix 3 by 3, like that. The matrix equals, hide this row and this column, and the matrix, it's become A22, A23, A32, A33, and apply the matrix rule. A22 by A33 minus A23 times A32. That's the first one. The second one, change the sign. Change the sign. Put negative. I can choose this column. If you choose this column, start from A11. Start from A11. Hide this row and this column. And the matrix in this case, it's become A1, A22, A32, A3, A23, A32, A33, and multiply A22 by A33 minus A23 by A32. That's the first one. The second one, choose A21. Negative. Hide this row and this column. And this matrix in this case, A12, A13, A32, A33, and apply the determinant. The third one, hide this row and this column. And the matrix in this case, it's become A11, A12, A13, A22, A23, and apply the determinant. The determinant, the by the minus the time the. Let's go to this example. If we have this matrix, to find the determinant, the determinant E, choose this row, or this row, or this row, or choose start from this column, or this column, or this column. By the way, we choose this A11, hide this row and this column. In the determinant, I can choose this column, or this column, or this column, or this row and this row, or this row. If I choose this row, start from 1, hide this row and this column. The determinant in this case, 2 by 1 minus 3 by 0. 2 by 1 equal 2, minus 3 by 0 equal 0. and choose 1, 0, hide this row and this column. 0 by 1 equals 0, minus 3 by negative 1 equal positive 3. But don't forget negative previous to this bracket. The third one, choose 1, hide this row and this column. 0 by 0 equals 0, minus negative 2, negative 1, 2 times negative 1 equals 2. The result equals 4. Give me the same result if I choose this column. Now start from 1, hide this row and this column. 2 by 1. Let's try 2 by 1 minus 3 by 0 equals 3. And choose 0, negative 0, hide this row and this column. 0 by 1 equals 0, minus 1 by 0 equals 0. Give me 0. Negative 1, give me 4. What do you notice? The same result. يبقى I can choose this row or this row or this row, or this this column or this column or this column, or this row or this row or this row, and apply the rule of determinant. This is very important example. You can use determinant to find the area of triangle. The area of triangle with vertices A and B, C and D, E and F. AB, CD, EF. That's the first projection and the second projection. Point, the first point, the second point, the third point. I want to get the area of triangle by using determinant by this rule. Half, that's the first projection, A, C, E, and the second projection B, D, F, and put 1, 1, 1 to determine the determinant. Example, find the area of triangle. The first projection 1, the first point 1 and 0, and the second point 2, 2, the third point 4 with 3. Find the area of triangle whose vertices are 1 and 0, 2 and 2, 4 with 3, as shown in the figure. To use the determinant, half and put the first projection vertically, column 1, 2, 4, and the second column, the second projection 0, 2, 3. We put 1, 1, 1, and determine apply the determinant. We get the result equal half. Please try to solve this exam. Thank you for listening.